Now, we have just learned that for similar figures, all the length was scaled by the same factor. But what happened to the area? This is where every student gets surprised. If the skew factor equals to k, if the linear skew factor equal to k, then the area ratio is actually k squared. But why k squared? Let me explain this step by step. You think about how we calculate area. For example, for a rectangle, area will involve length times width. So we are dealing with two dimensions, not just one. Whenever we scale out a figure by a factor k, both dimensions get multiplied by k. So the length becomes k times longer, the width becomes like k times wider. So the new area equals to k times length multiplied by k times width. If you multiply this out, you will get k squared times length times width, so which means k squared the original area. So looking at the same rectangle that we just saw earlier on, we know that the scale factor is 2.5. If you want to find the area of the larger figure, what will you do? If the scale factor is 2.5, the area of the larger figure equal to 2.5 square equal to 6.25 times the area of the smaller figure. That means the larger rectangle has 6.25 more area than the smaller rectangle. Does it make sense to you? Think about it. If the smaller rectangle has an area called A, the larger rectangle has an area of 6.25 times A. That's more than 6 times bigger. So even though the length increased by only 2.5 times, the area increased by 6.5 times because both the length and both the width increase. Remember our cake example from earlier? If you want to double the size of a cake, you don't need double the ingredients. You need 2 square the ingredients because the area of the cake base becomes 4 times bigger. Now let's move on to 3D objects. From similar figures to similar solids. Here, the mathematics get even more complex. If the linear scale factor equals to k, then the volume ratio equals to k cubed. That means k multiplied by k multiplied by k. Why k cubed? You think about it, we previously learned that area uses k squared because area involves 2 dimensions, length and width. Well, in this case, volume involves 3 dimensions, length, width, and height. So when we scale out a 3D object by a factor k, all 3 dimensions get multiplied by k. The length becomes k times longer, the width becomes k times wider, and the height becomes k times longer. So the volume equals to length times width times height, and so the new volume becomes k times length multiplied by k times width multiplied by k times height. When we multiply all this out, we get k multiplied by k multiplied by k multiplied by original volume, which is equal to k cubed times the original volume. Let's work this out with a cube example. We have 2 cubes here, a small cube that is 6 cm and a larger cube that is 15 cm on each side. Our scale factor, let's assume, is still 2.5. How can we find the volume of the big cube? If the scale factor k equal to 2.5, the volume of the larger cube equal to 2.5 multiplied by 2.5 multiplied by 2.5, which means 15.625 times the volume of the smaller cube. Let's try to visualize this. If the small cube has volume V, then the big cube has volume 15.625 V. If you imagine yourself trying to fill the big cube with the small cubes, you will need more than 15 small cubes to fill the big cube completely. Remember our earlier cake example? If you want to make a cake that is twice as long, twice as tall, and twice as wide, you will need not just 2 times the ingredient, but 8 times the ingredient. Similarly, if you think about swimming pool, if a swimming pool that is just 50% larger in one direction, let's say a scale factor of 1.5, you might end up having to hold 3.375 volume of more water, because 1.5, if you cube it, will become 3.375. Now let's summarize what we have learned in this table. For any measurement that involve length, like the side of a square, radius of a circle, or height of a triangle, these are all one-dimensional measurements. The ratio between the similar figure is simply k, the scale factor. For any measurements that involve areas, like the surface of a rectangle, the area inside a circle, or the face of a triangle, these are two-dimensional measurements, and the ratio becomes k squared. For any measurements that involve volume, like the space inside a cube, the capacity of a sphere, or the amount a container can hold, these are 3D dimensions. The ratio becomes k cubed, which is k by k by k. The key to ask yourself is how many dimensions you are facing. If it's one-dimensional, use k. If it's two-dimensional, use k squared. And if it's three-dimensional, use k cubed.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.